But I think for some people, most questions, they can't. So I would have to do every question anyways, you know. If those people show up. So like if it's just the two of us, then of course I won't do a question that you said, oh yeah, no problem. But if everybody's here, then I might have to do everything. Okay. Let's get started. I need to open the program here and then the lesson. I'm hungry today. I had 2 breakfasts and I'm still hungry.
I don't know what. Even yesterday.
Maybe it's all the sunshine.
But it should make you thirsty, not hungry.
It's different here, maybe.
No, it's the aircon.
I suppose it is. Right, let's see. Come on, there we go. Maths part 2. Maths for engineering.
I think the probabilities are easier than the statistics.
Which is good, because that's what you get on the exam. The probability.
More than the statistics.
Much, much more. It's good news. Okay, let's have a look at some ideas here. So, let's imagine... Oh, come in. Ah, yes. So, as I was saying, let's imagine we have something like students doing some experiments in physics. So we'll have person A. Person B. We'll do a few people. Person C. Person D. Person E, for example. And let's say these people, they're doing experiments where they have to, I don't know, calculate the value of G or something like this. So the first person, they do it one time and they get 9.8, which is good. They do it again and they get 10. Then they get 9.9, 9.7, 9.6. And then maybe they do one really bad and they get 9. Then they get 9.8 again. Oh, no, that's too bad. And then they get 9.8 and then they get 9.7. Something like this. And person B will say they get 9, 10, 9.5, 9.6, 9.7, 9.8, 9.8, 9.8, for example. Person C, 9.8, 9.8, 9.8, 9.9, 9.9, 9.7, 9.7, 9.8, for example. Person D, let's say they get 9.8, 9.9, 10, 10, 9.2.
Yeah, I got 3 in the experiment.
Oh, if I'm 3, this can be you then. 9.8, 9.8. Okay. And then person E, 9.8, 9.7, 9.6, 9.8, 9.7, 9.6, 9.9, 9.9. Okay. So they each do the experiment about 8 times, and they each decide, okay, actually let me just put in an extra column here. Sorry. Mean. So let's just get the mean average. So the first person, they do the experiment 8 times, and then they calculate their average G from their data. And they come out with an average of 9.6875. And then this person, they get an average of 9.65, 9.8, 9, 9.75, as an example here. So, let me just shrink this in, I need a bit more space. Now, if you were looking at this experiment, you might wonder, okay, this was done many times by many different people. On average, what does each person get? So you would have to average these 5 numbers here. And you see these 5 people, they got on average 9.5875. So when you look at all the results, this 9.5825 averages everybody. It averages the 5 people, and the 5 people were averaged from their data. So in some sense, this is our best estimate of the true value, this 9.5875. So we could estimate G as being around about this. So you could say G is roughly 5825. But of course, just like in physics, you know there's an error. So there's a plus or a minus here. Yeah. So we could get, the G, that's its average. And we'd like to know the standard deviation, or sometimes it's written as S, for this prediction. So when you look at the type of values people get when they do this experiment, you see it doesn't change too much. Okay, 9 is quite a bit different, but for most of them, 9.6875, 9.65, 9.89, 9.75, they don't change too much. So underneath, what I'll do is I'll get the standard deviation. And I'll get the standard deviation of the 5 results here. And we get, mistyped. Oh no, it's not that, it's STDEV. 0.316. So what you're saying is, on average, what value do people get for G? They get 9.58, yeah? But what do you think this 0.3169, the standard deviation, represents? How would you interpret that? What do you think?
How they are far from the 9.5.
Yeah, how far they are. Which, if you think about it in physics, that's what we were calling the uncertainty. The only problem is, when you do this experiment, so let's just imagine that this is you, for example, you got 9.75. Is this the true answer? No. We think the true answer is 9.58. And also, you don't have this data, so you don't have a standard deviation. So what you would love to say is, you would love to say your answer is 9.75, and there's a standard deviation of something like 0.25. So if you picture it as a bell curve, what you're saying is, you think the G is 9.75, but it could change a little bit. So it could be as small as 9.25 or as big as 10 we add on a half, 25 there. So we know how to get that. We just average our data. But how do we get this? Because we got that standard deviation from looking at everybody. Let's see what your standard deviation was, and maybe it might help. So your standard deviation is 0.119. Yeah, I think I got that right. Yeah, and let's look at the other person's. Oops. 2.43, 0.075, 0.302, and then 0.3. Now, I think because I was making up the numbers, it's not going to be as good as I was hoping. Let me just check something here for you. Yeah. So because I made up the numbers, it didn't really work nicely. But there is a way that you can use your standard deviation to estimate the standard deviation for the whole sort of population. Now, I don't think it will work here. I think it'll be actually quite bad. So if you take your standard deviation and divide it by square root of how many points you have, which is 8 points. Yeah, it's quite bad. I think the reason this is quite bad is because this is quite big, and the reason it's quite big is because this is quite small, and the reason this is quite small is because you've got a 3 here. So let's just change that to a 9.8. Much better. So the standard deviation for the population is 0.089. When you use that trick I suggested of using your standard deviation divided by the square root of your sample, you get 0.04, which, is not too far away from the true answer. So what you can say is, I got a G of 9.75 and my standard deviation was 0.119. If I use my trick and divide by square root n, then you have a standard deviation of 0.04. So what you're saying is, on a bell curve, the average is 9.75, but it could be as small as this minus 2 of these, and it could be as big as this plus 2 of these. So what you're doing is, you're trying to put some limits on your experiment result. You could do the experiment with many people, but of course the point is you have limited time and resources. So what you'd love to do is take your set of results and try to work out what would the standard deviation be if you did it for many people, and then this way you can kind of put limits on your value. So you got 9.75, and you think that the standard deviation of your result is about 0.04. So this should kind of remind you of what we did in your lab reports, the uncertainty. So we call this average plus or minus, say, 2 standard deviations. Really, rather than calling it standard deviations, we call it standard error, because that's what it is. It's like an error on your experiment rather than a standard deviation, because the standard deviation we didn't use. What we used was the standard deviation divided by square root 8. So just to make that clear, standard error, which is like standard deviation, except you divide by root n. And this kind of puts what you might call an error on your results, sort of limit. We said 2 covers most of the normal distribution, but you remember yesterday we were looking at how far left and right you have to go to get different percentages. So if you just go back to yesterday's lesson, or was it the day before? Yeah. Remember this question here. It said find the Z, so you get these different percentages. So this last one here, or this one here, 99.45, the Z was 2. Meaning, if you use 2 standard deviations, you would be covering 95% of the possibilities. In physics, what you didn't realize when I gave you the formula is you were actually using 1 standard deviation, so you were covering 68% of the possibilities. Meaning that your estimate would only be right with the limits 68% of the time, and about 32% of the time your estimate will be outside the true value, or rather your true value is outside the estimate. In the exam, the most common percentage they ask you for is 95%, and this is the one I said you have to memorize. 95%, do you remember what it was? 1 point? You got 2 of 3 the numbers right. 1.96. 1.96. So, if you use your average plus or minus 1.96, your standard deviation, or in other words, your average plus or minus standard deviation over root n, you've made something called a confidence interval. And what you're saying is that the true mean, if you could do this sort of infinite times, many times, not just like 8 times or whatever, the true mean would be smaller than your mean from the sample you have plus 1.96 times your standard deviation. I think I'll use S. That doesn't really matter. I can't remember which letter they use in the formula book. I have a feeling they'd use sigma though. Bigger than your average minus 1.96 your standard deviation over root n. So the true value of the mean average should be between these two numbers. Not 100% of the time, 95% of the time. So this is a 95% confidence interval. Yeah. This is useful because I don't know if you've ever seen surveys or questionnaires on TV where they say like 20% of people would vote yes or whatever, and then at the bottom they would have something called the error, and they'd write something like plus or minus 2%. So what they're saying is, okay, we interviewed many people and 20% of them said they would vote yes, but of course that doesn't mean in the whole population 20% would vote yes, because you're only looking at a small sample. You need to have some kind of error on your measurement, and they would calculate this in the same way we would calculate it here. It's the same idea. So this is like our formula for today, and the only thing that might change in the exam is this number. But I would bet good money that they would keep it at 95%. Not guaranteed, but one thing that makes me think this is that in the formula book, when they give you this confidence interval formula, they actually use the 95% version of the formula, which makes me think, so that's what they would probably ask in the exam, because that's the one they have in the formula book. Now, there's no rule in the syllabus that says they must use that one. They could ask for the 99% one. And if they do, bad news for you, you have to do what you did here in this question to work out how many standard errors you would need. Okay? So we can have a look at some questions, but first you probably want to write this formula down.
The name of the system.
Confidence interval, yeah. Oh, and here's the other formula. Standard error is what we call the standard deviation divided by root n. And 1.96 is what we use for 95%. Got that? You wrote that down, yeah? Okay, let's have a look at some questions here. Okay, just to be technical about it, but it's not something you need to know for the exam. There is a tiny difference between this and this. For us, I'm saying that they're the same thing, standard deviation and the standard deviation from the sample, or standard deviation. There's a tiny difference in the formula. This one here is square root sum of x average minus xi squared over n, where this one is sum x average minus xi squared over n minus 1. Now the syllabus actually says students should only use this one, not this one. If you go on to university and do something like this, I doubt your university lecturer would allow you to use this one only and not this one. There's actually a different situation for each. The difference is you use this one when you have everybody. So if you know you have everyone in your data, you didn't miss anybody, you use this formula. However, if you know you only have a sample and you don't have everybody, even if you're missing just one person, then you use this formula. But in fact, if the n is big, these two are about the same anyways. It's only more of a technical mathematical reason. Something not part of this course, but something that would be part of a university statistics course in engineering. Okay, so let's have a look here. Maybe we'll do a couple together. Do you have your calculator? You have your Casio. Let's learn how to quickly calculate means and standard deviation on the Casio calculator by using the statistics mode. You're going to have to open it someday. No? You got your Casio? Do you want to sit beside Missouri?
Moment for life.
Room for life. So you know the formulas to calculate it, but to save time, there is actually a statistics mode on the Casio calculator where you can just type in the numbers and it can calculate it for you. Now I think I remember how to do it, but we'll test it on mine. Do it. Feels good, doesn't it? Yeah, it does.
Take my house.
Be strong. Oh my goodness, don't break it on the first day. Actually, we won't do the statistics one right now. Okay, let's have a look here. So, more on it. Yeah. Okay. All ready? Yeah. I think, if I remember, if we press mode here, we have a stat option. You see that there? Yeah. On me, it's number 3. No, that's a different thing. I think so. Or maybe not. Hang on. There's a stat button here as well, isn't there? No.
Yes, in one. Okay.
Yeah. Anyways, mode, statistics, and I don't think it matters too much what we pick, which mode, but I'll just put the first one to put it. Yeah, first mode. So I'll do that one more time. Mode 31. We have this table. So what we can do is type in the numbers on this table. So 20.0501, 20.2501. I've just typed in these two here. Got those? Okay, now I'll just gone too far down. Let me just move this to the left. Right, next one is 20.3801, 20.1601, 20.7901, 19.8401, 19.9601, 19.6001, 20.2701, 20.5501. I have 10 here. Yeah, now let me just check. Yeah, if we press, now don't you do it, just check 'cause this might be wrong. Shift 1, 2, no, maybe I have to press AC. Okay, Shift 1, 4, yeah, that's it. So if you now press AC to go back to the main menu, so to speak, and then if you press Shift Statistics, Shift 1, and then if you pick 4 for variables, you get a list of things you can calculate. So the average is easy to calculate. Let's calculate the standard deviation, which is number 3.
How can I calculate
Number 2? You know how to get the average. You add all the numbers. Well,
about that slide to calculate?
oh, well, press 2 here, and you get the average. Or if I do Shift 1 variables and pick 3, I get the standard deviation. If I wanted the confidence interval, I could do Shift 1 average plus 1.96 times standard deviation over square root, and I don't even have to count them because I can do Shift 1 variables n.
Where did you get this? X?
No, that x is just printed on the screen. It's not really an x, it's a sigma just. So 1.96 times standard deviation divided by square root n. So that's the upper, and then I change this to a minus, and that's the lower. Were you able to get that typed in? What did you get? For the confidence interval? Well, you did the plus one, you should have this. You have 1.96?
Isn't it supposed to be all divided by square root n?
Yeah, but that doesn't change the answer. But if I put it in brackets here, see, it doesn't change it.
Oh, it's just the last part divided by n.
That's what I typed in, yeah. You got it now? Yeah? Okay. So, for example, in question 1 and 2 and 5, you can use the calculator like this if you want. Let me just check something here, the answer. Yeah, so the reason I gave 2 answers here is because it depends on which formula you use. The n or the n minus 1. I kind of don't want you using the n minus 1. That's not on the course. I don't know why I put both in. Maybe I'll delete that later.
Well,
But, yeah.
You said that it's equal to standard deviation over root n.
The standard error is equal to the standard deviation over root n, yeah.
Then what is the x?
Standard deviation. It's just, there's a small difference. We use the letter S when it's a sample, and we use the sigma when it's everybody. But for us, right now, in this course, there isn't really a difference. The only difference is We use S when we want to show it's a sample, and sigma when we want to show it's everybody. But you can use both, it's no problem. In fact, let me check what they use in the formula book, because I have a formula book here. IFY, resources, formula book, and where's the engineering formula book? I'll show you this in the formula book. Okay. That's semester 1, semester 2. There's trapezoid and Simpson's rule. Normal distribution, and they use sigma, and you can see that they have 1.96 there, as I said. And this is the formula for the Z transform, and this is the table for the normal distribution.
So if they ask of the Z group for the 95%, the answer is in the formula.
Yes. So why students do badly in this test? I do not know. But you're right, the formula is right here. No, you don't. And like if we just have a quick look here at, I think I have last year's, oh my goodness. Past exam papers. I know there's a confidence interval one in it. So for example, yeah?
I want to do it by, not by the calculator. What is the X mean?
No, which X?
X and formula.
This X is average. Yeah. If you look at the exam, can you see that question 12? Have a look at 12. The times taken to produce a component can be assumed to follow a normal distribution with mean 125 and standard deviation 5. What percentage is between 117 and 133? What type of problem is that? This one here. The time taken to produce something is a normal bell curve with average 125 and standard deviation 5. What percentage will be between 117 and 133? Yes, you missed this class, but you should know this. What do you do? The Z transform, yeah. So you draw your bell curve, and we have here 125, and we're looking at 117 to 133. And the standard deviation is 5, and they want to know this area here. 5 marks. But I do think there was a confidence interval one in this exam. No. Maybe in another paper. Possibly. I don't know why it's in this docx format, but let's have a look. So yeah, you missed that lesson on, I think, using this formula, right?
This formula, then to use the Z value in the table.
Yeah. So really it's not much different to the first lesson. Oops. Okay, here we go. blah, blah, blah. Newton Raphson. Again, yeah, this one is only below 1477. Oh, you know what? I can just search confi confirm. No. There we go. So we want the confidence interval here. In fact, they don't even want the confidence interval, they just wanted the maximum value, I think. So I have to look at the question, but I feel like they were just asking for this half of it. Anyway, the confidence interval, 3 marks. So that's okay. Come up again, confirm, confidence, yeah, that's it. So, you know, I was saying to Musharif just at the start that probability comes up more in the exam than statistics, because if you look at section A, you have a probability question. What's the probability that all 3 letters are I? So 3 letters are chosen from the word divisibility. What's the probability that all 3 of them is an I? So you get an I the first time, an I a second time, and an I the third time. It's a bit like what we did in semester 1 with the balls in the bag. You know, you get a red the first time, a red the second time, a red the third time. Also 3 marks. So the probability is a good question on the exam, because a lot of the exam is calculus, and some stuff from semester 1, like the sine and cosine rule. Remember these problems, getting the area. And then, I know this because my version is messed up, getting the volume.
The lesson that I was that
you did do it?
No.
Are you sure you didn't do it? It would be so strange if he skipped that one lesson for some reason, the practical problems. It's calculus semester 1, a lesson that deals with finding the maximum profit, the maximum area, the minimum cost, all these types of things.
The rectangle.
Yeah, maximum area. So what's your feelings telling you, Musharif? Think you did it or you didn't? Did you miss any classes in semester 1 for maths?
No.
Are you sure? I will email and ask. If he didn't do it, then I guess we have one more maths lesson left. Or you could watch the video from semester 1. Remember I gave you the name of it?
I didn't write it in my phone.
Okay.
No.
Do you want to write this down as well? Or do you even want to search for it and then mark it to watch later? Do you want to search for it or just write it down? Maybe you should search for it. You know my YouTube channel. You must be your homepage, right?
Yeah, my YouTube.
It's all me.
Yeah.
The name for this is, you should type in on my channel calculus, CALCULUS, practical problems, PRACT. You know what? It'd be easier if I just write it down. Oh, you got it?
Yeah.
Can I have a look at the video thumbnail when it loads? Make sure it's the right one. You haven't loaded already?
Which one?
Which would be best? No, it's not that one.
No.
4 months sounds good. Can I just see? 4 months would be a good one. And this one here is from 2 weeks ago. That would be the most recent one. Yeah. But I have a feeling that this one is a bit longer, probably because I did more examples in the class. And this one was good as well. This one's good as well. Yes, they all look like they'll do just fine. So you probably want to pick the one like this one here, the longest one. Or even a more recent one if you want to save a bit of time. Yeah, you could go with the one from 2 weeks ago.
And you said you solved the question in the tutorial.
In the tutorial, so if you type in calculus, or if you type in tutorial from about 2 weeks ago, can you go back and search, and if you could type in tutorial. Oh, are you searching all of YouTube?
Yeah.
Then can't you search my channel specifically? Because there's like a little...
Well, open like one page.
Yeah, so is this button here to search my channel?
No.
It's not. Oh, it is on the laptop or something like
Yeah,
it.
it is on the laptop.
Alright. So if you want to go to about 2 weeks ago, so I guess if you search my channel again, and click, or can we go back to 2 weeks ago? Right. No, not this, maybe the one before, I keep going. Right, here we go. Maths Part 1 tutorial, and I can recognize from the picture that this is the tutorial on practical problems, or at least I did one question in it. Can we just like jump to the middle of it or something? A little bit more forward. I guess I do other stuff. Yeah. This is a good one as well. This was from the homework worksheet as well. So yeah, you could watch that one too. If after watching it you're not happy with it, we can do it in class. But you should try to watch it first. Yeah. You haven't watched it yet. Too busy?
I forgot.
Yeah. Alright. Do you want to take a break for a couple of minutes, and then when we come back we can have a look at doing some of those questions?